Let's go ahead and explore the basics of CI/CD. In a typical project, source code resides in a Git repository where it's both stored and versioned. GitLab is a web-based platform centered around Git, serves as a centralized hub for hosting these repositories, and extends Git's capabilities with additional features. Typically, all code resides on the main or master branch, which is frequently deployed to production servers or environments. When there is a need to introduce new features or simply modify existing code, developers create and collaborate on what's known as a feature branch. This branch essentially functions as a clone of the main code base, enabling a team of developers to work on a new feature until it's fully developed. Once the necessary changes are made, the code is committed to the feature branch, and a pull request is initiated to merge this code back into the main branch. But before the merge takes place, a review process is carried out and the changes require approval from relevant team members or individuals. Following a successful merge into the main branch, the code is then deployed either manually or through an automated process to the production environment. This situation poses a significant risk to the application's stability, and as there are often no testing conducted on the newly merged code before it reaches the production environment. In real-time scenarios, you will often find multiple developers working on different feature branches, each focusing on a new enhancement. Performing multiple merges without the implementation of continuous integration in a software development workflow can lead to several significant problems and challenges such as delayed testing, inefficient deployment, and quality assurance challenges. Talking about delayed testing, without CI, testing typically occurs late in the development cycle, often after multiple mergers have taken place. This delay in testing can make it harder to identify and rectify issues early in the development process, which increases the risk of defects making their way into production. Talking about inefficient deployment, in the absence of CI, deploying code to various environments like dev, stage, production often relies on manual processes. This can lead to inconsistencies in deployment and potential configuration errors. And finally, without automated testing as an integral part of the development process, ensuring software quality becomes more reliant on manual testing, making it prone to human errors and subject to resource constraints. So now let's imagine a scenario where a developer 1 creates a feature branch A, makes some modifications, and commits the code to this branch. A pull request is generated to merge these changes into the main branch, but before the merge, a team member reviews the code and an automated CI pipeline is triggered. The CI pipeline proceeds through several stages, including unit testing, dependency scanning, artifact building, and vulnerability code scanning. All these assessments are performed on both the newly added code and the existing code from the main branch. If any of this test fails, the developer is asked to make the necessary adjustments and commit the changes to the same pull request. This action triggers the CI pipeline again, and if there are no failures this time, the pull request is approved and merged into the main branch. Upon merging into the main branch, the same CI pipeline, or possibly a different one with additional steps and tests, is automatically executed to verify the merged code. At this point, testing the same code again after merging may seem redundant, but I'll try to clarify this by the end of this video. So while these developments are taking place in feature branch A, developer 2 is progressing on a feature branch B. They commit the changes and create a pull request, and whenever the pull request is created, an automated CI pipeline is initiated, testing the code committed in this new feature branch B. So once the CI pipeline successfully completes, the pull request is approved and it can also be merged back to the main branch. So following the successful merge, the main branch now contains the code changes from both feature branch A and B. As mentioned earlier, any merges into the main branch should automatically trigger a CI pipeline. In this instance, it once again runs all the tests, including the unit test, dependency scanning, artifact building, and additional vulnerability scans. This ensures that the code changes from both feature branch A and B work seamlessly together. This entire process, which enables multiple developers to work on the same application while ensuring that these changes integrate smoothly without introducing any issues, is known as continuous integration. So far, we explored the concept of continuous integration. Now let's check into the CD part, which could be continuous delivery or continuous deployment. So in the previous instance, after a code integration is done into the main branch and successfully completion of the CI pipeline, manual deployment to the production environment was performed. In many scenarios, even after rigorous CI and testing procedures, it is advisable to deploy the modified application to a non-production environment that closely resembles the live environment. This allows for live testing before proceeding with production deployment. So within the same feature branch, following a successful continuous integration pipeline run, we can establish another continuous deployment pipeline. This pipeline should be responsible for deploying the modified code to either a staging or a development environment. So following deployment, a series of tests are executed to ensure that the quality of the application does not get degraded. Upon successful completion of CD, the pull request is approved and merged back into the main branch. So within the main branch, the CI pipeline is triggered assessing the newly merged changes. If successful, it automatically initiates the CD pipeline, which results in deployment of the application to the production environment. This automatic deployment process following successful continuous integration is often referred to as continuous deployment. In certain instances, a manual approval step before production deployment is a critical aspect of the deployment process. This step serves to minimize risks, ensure quality, adhere to compliance requirements, and effectively coordinate changes. It offers a safety net and allows for human judgment and oversight within an otherwise automated process. So in this scenario, following the successful completion of the CI pipeline, the CD pipeline awaits human approval before proceeding with the production deployment. This process of manual approval prior to production deployment is known as continuous delivery. Thank you.